Hi guys, we are live and today we will check the next task. So let's take a look. So we are on our roadmap, right? And we are on slide in the window. We see this task with long repeating character replacement. So let's revert it. So we remembered we didn't solve this task. Let's remind this task and let's try to analyze this task. So I will try to maybe run Excalibur and just analyze it. So let's check. So let's remind. So we have a string with uppercase letters, and we also have integer k. That means how many characters of the strings I can choose and change. And I can perform this operation at most k times. And we see that it's 10 over 5, so if we will have n squared, it would just run out timeout exception. So we have to return the length of the longest substring containing the same letter you can get after performing the above operations. So how actually we can do this? So we're thinking like about a sliding window. So by sliding window we see kind of this one. So yeah, so we start with A, we perform A, B to A, and this one, like if we consider A. But we can have another test case like this, and k equal to 1. And in this case, we will consider A, we change A, and we will have 4, and it also works. But what if we have something like this, and we have k equal to 1? Then we start with B, and we try to change this A to B, so we change it. So we change this A to B, and we have 2 elements, right? Yes, that's correct. But that's not actually the valid answer because we have 4 here. If we consider A and we change B to A, then we will have 4 elements here. So how actually to solve then this question? How actually? How to solve it in this case? I don't know, like in this case, I don't know. We can check hints, but here we don't have hints. We can have, as I said, like some hash map. So we can have like a map where we calculate number of elements. So for example, we calculate 3, and here we just see that we should start with A. So when we see some element B, we just change it. But here we can have something like this, right? So we change this C, and this would not work. We change this one, and we go next. So I think this map can help us actually to solve the question. What else? And if we will check topics, we have hash map, sliding window, and string. So am I sure that this one is like correct implementation? Let me check tutorials. We don't have. Let's check here. Yeah, so we have some implementations here. So we have lengths of our string. We have kind of hash map. Okay. We have start, max count, and max length. Okay, we go just by string. We have our max count. It will be max count and plus plus count. So we first add 1 to this element. Okay. And while end minus start plus 1. Yeah, I think it's quite complicated actually. There is no edge case for this question. The initial step is to extend the window to its limit. That is the longest we can get with the maximum number of modifications. Until then, the variable start will remain at 0. Then end increases. The whole substring from 0 to end will violate the rule. So we need to update start accordingly. We will start to the right until the whole. Okay. Yeah, I think I got the logic, but implementation is quite hard. Do we have here something other? Okay, so here almost the same. We consider some array. We increment this array. We check if max count less than number of these values. Yeah, max count is okay. And here, like end minus start minus what does it mean? What does it mean? Let's check this one. Change. Okay, so let's check this one. The question asked to find the longest of string. Okay. Here we know that we can change one character to mix up strings that is valid answer. Okay. Okay, so sliding window left and right. Know that our current window substring is valid when the number of characters that need to be replaced is less or equal to k. Let's take the example below to understand better. So if we have something like this, and we have k equal to 2, so we can like change this b, right? And this b. So result will be like 5/8, right? So left 0, right 4. Yes, that's correct, 4. This example above shows a valid substring window because we have enough k changes to change the b's to a's, right? We will need to know how many letters in our substring that we need to replace. To find out the letters to replace, and minus start plus 1 is so they use the same like letters to replace and minus start, but you see, like, he doesn't consider any end. What does it mean, end? Who is this guy? Okay. So he is Microsoft software engineer. Does he Microsoft software engineer? 9 seconds. Okay. Yeah, indeed. All right, but it's interesting, like how he explains, and he just used first time and here, right? You see, and that's it. So we will need to know how many letters in our string that we need to replace. To find out the letters to replace, and minus start plus 1 minus most frequent letter. Pretty much you take the size of the window minus the most frequent letter, that is the current window. Now that we know how many characters that need to be replaced in our window, we can deduce that if letters per place is greater than k, then the window is invalid and we increase the window size from left. The window is invalid and we decrease. Okay. Pulling the whole, so let's check the whole algorithm. Okay, so we have most frequent letter, frequency, left and max. Okay, and he has also this right, left and right pointers. Okay, so right is always increasing by 1. He increased frequency, most frequent letter would be most frequent and frequency, right? Yeah, I think I need to charge. Let's go charger. Okay. Most frequency letter. So by this most frequent, we just know what letter is most frequent and letters to change. So letters to change, it's our right minus left plus 1 minus most frequent letter. So I think this line is the most important thing in the question. And we have to understand what actually does it mean. So for example, here we see C, right? And we have our map, let's say. So we see C is 1, right? And most frequent letter would be 1. Okay, then we letters to change, it would be right minus left plus 1. It would be 1 minus 1, so it would be 0. So 0 is not greater than k, because with description we have k, it can be 0, okay. But 0 is not greater than 0, right? So we don't need to decrease frequency. Okay, so we go to B. We increase this is B1. Also we calculate this B1. Frequency will still be the 1. And right by letters to change. We have to change some letters right now. So it will be 1 minus 0. plus 1. So here it will be 2 minus most frequent 1, right? So we have 1. And let's imagine k is 1. So 1 is not greater than 1. So we actually can continue our sliding window. And the next window becomes a that is equal to 1. Frequency is still the same, but here it becomes 3 minus 1 will be 2. And now we see that we need to decrease our sliding window. So we decrease in our sliding window, and we have our left pointer. So we have left 0 and right would be 2. So what do? We take our frequency map and we remove our C and we also have our max, right, every time. So max, it's actually max 0 and right minus left plus 1. So yeah, so here it will be 2 for now. Okay, so now we see that we need to decrease our sliding window. So we decrease C. Okay. When C, decrease C and increase left, right? With 1. Left will be increased. Letters to change. So yeah, so here is a while loop. So we just decrease it by 1. Now right minus left, it becomes 1, but max is 2, so we don't need it. Then we have another A right here. We have another A, and with another A, we increment our map. Most frequent letter becomes 2. And now right minus left plus 1 minus 2. What would be? Like 2 minus 2. Like 2 minus 1. 1 plus 1, 2. And here it would be better to change 0. And 0 is not greater, so we just calculate right minus left and we check. Okay, I think that's understandable. Let's try to implement it with just understanding. So how it works? So we have our result that it will be 0, right? And we also have our frequency map. It will be not map, and it will be an array of 26 elements. Then we have a left position, and we also have max frequency. Then we have right. And what we now have here. So first of all, when we see our element, we should increment our frequency map. So we take our character, so it would be as char at right minus a. So we increase our frequency. Then we should update our max frequency. So it would be mass maximum between mass frequency and this value. Okay. Then we have to calculate this, the most important thing. So letters to change. And letters to change is actually how it's calculated. So we take right minus left plus 1. So it's our like sliding window minus like when we are, let's check, like when we on C, I increase my frequency, C, yeah, and minus 2. So minus max frequency, right? And now I check if letter to change greater than K. Then I have to update frequency. Of left, and also increment my left. And here I should update my result. And right minus left plus 1. And then return my result. Okay, so let's check this logic. Okay, so I have my C first. It would be 1. Then max frequency would be 0, and this one, so it would max frequency would be 1. Left 0 and right 0. Now I calculate letters to change. So 0 plus 1 equals 1 minus max frequency 1. So it would be 0. So 0 is not greater than K. It would be 1. So I'm not given here, and I update my max with 0 and 1. So my max will be 1. Okay, then I go to B. And now with B, I calculate plus 1. Then max frequency is still 1. Right minus left. So right right minus left. So now right would be 1 minus 0 plus 1, 2 minus 1. So now it becomes 1. And here 1 is not greater than 1. Correct? So I just update it, and now I have right that is 1, and here now it would be 2, max 2. Now I go to A. And when I'm on A, I have 1. Now max frequency would be still 1. But I update my rate to 2. Plus 1, 3. 3 minus 1, 2. 2 is greater than 1. Mm-hmm. 2 is greater than 1. So I have to update C to 0 and move right to 1. Okay. And now I calculate 2 minus 1 plus 1, it would be 2. Then I go to another A. I update this A to 2. Max frequency becomes 2. R would be 3. 3 minus 1, 2 plus 1, 3. 3 minus 2 would be 1. So 1 is greater. So now 3 minus 1, 2 plus 1, it will be 3. The result currently max is 3. Then I have another one, it will be 4. So result should be 4. So let's run. Max result. Okay, accept, submit. Yeah, and we solve this question. Very nice. Yeah, I think the main thing is actually to understand this line, because here we just update our frequency, but yeah, to understand that mass frequency is actually should be in this slide and window. Yeah, so I think it's quite a nice question to ask. That's all for now. See you next time.